Hi all. In my ongoing tutoring of students struggling with basic algebraic problems, I've hit a number of students who've run into a problem with long division. Hence I'm making this video. There are just a couple of tricks to learn, but it's actually a lot easier than what it seems. It seems overwhelming to a lot of students in the beginning, and I'm hoping to debunk a lot of those problems for you all now. What you're seeing here is a typical long division problem, but we need to figure out how do we start it off, and we need to have a very systematic approach on how we're going to do long division. First of all, let's make very sure that you can deal with problems of this nature. These are single term problems. You should be able to look at this and immediately say that the answer is 20 divided by 10 is 2, x divided by x to the power 3 is x to the power 5, 8 minus 3 is 5, y to the power of 8 divided by y to the power 4 is y to the power of 4, because 8 minus 4 is 4. If you're struggling with these problems, you need to go back and have a look at the video where I deal with this. And that is on the video on exponential rules. Okay, we need to resolve some terminology. In this first one, this is a very simple thing. 7 divided by 2 equals 3, remainder 1. 7 is the dividend. 2 is the divisor, 3 is the quotient, and 1 is the remainder. That one remainder is actually one of 2. So it's actually a half. I want you to remember that, because that's going to become clear when we do algebraic division. We need to actually understand that properly in algebraic division, long division. But that 1 actually represents a half to make up the next level. Just remember that. In long division, we have the quotient at the top. We put the dividend inside the bracket, so we create a little bracket like that, and the divisors in the front. And when we finish doing the sum, the remainder is at the bottom, but that remainder now will be 2 upon 6, or a third. And I want you to remember that, because that's very important in algebraic long division. Let's look at types of division that we do. That's called a monomial expression. It's mono, meaning one. It's got a single value divided by another single value. Very important. This we do not do long division on this. It's a polynomial expression. So it's got multiple terms separated by plus or minus. Notice up there, there are none. Divided by multiple terms down here. And we need to understand that we only apply algebraic long division to polynomial expressions. Okay. I want you to follow very carefully what I'm going to say now. You need to inspect your problem very, very carefully. Sometimes you're faced with something like this, and there's just a trick to this. And you need to be aware of these tricks, and you need to be able to see them. Now, granted, this trick is a little bit more complex, but you need to be able to see it. It'll be much more obvious at certainly the grade 10, 11, or 12 level to be able to factorize first. And I'm going to try and show that to you. So, this appears to be a polynomial divided by a polynomial. But we may be able to change these into monomial type division by simple factorization. So, if you take this expression at the top, a cubed plus 5a squared minus 19a plus 27, and you factorize it, if you don't know how to factorize, go and look at a previous video of mine on factorization of algebraic formula, into algebraic formulas. So we've now got a single term multiplied by a single term multiplied by a single term, and the moment we do that, we actually have a single term. And we want to divide it by, we factorize the bottom part, a squared plus 8a minus 9 is a minus 1 multiplied by a plus 9. And now we've got a single term divided by a single term. By simple cancellation, remember they're written on top of one another, so we can cancel the a1 out and we can cancel the a plus 9 out. We've got a minus 3 divided by 1 at the bottom and a minus 3. Now that is a very simple solution, and we need to be very, very aware that we need to inspect our problem very carefully and see if there's not obvious factorizations that could happen. The answer would be the same if you did long multiplication on this. It just takes a lot longer, and it's a lot more complex to do that long division than to do simple factorization and get it out. So the bottom line here is, be careful. Inspect your problem very, very carefully, especially in an exam or a test situation, and factorize first if you can. Let's get on with the real object of this video, which is the method that we use to do long division. Given that problem, minus 5x plus 2 minus 6 minus 6x plus 3x squared divided by minus 4 plus 3x minus 2. The first step you do is you rewrite this equation properly. And you rewrite it in descending powers of x. So we've got 3x squared, that's the first one. Minus 11x, minus 6x, minus 5x, minus 11x. And plus 2 minus 6 minus 4. We simplify it and rewrite it in descending powers of x. We do the similar to the divisor. We look at this carefully and we see that we cannot factorize. Very important. You've got to look for factorization. So inspect it, you see you cannot factorize. And we write it as a long division problem. Dividend, divisor, and we now ask ourselves the question. If we take x and we try and divide x into 3x plus 2, we get an answer. And we write that answer down. Now notice what I've done. X goes into 3x squared 3x times. But I've written the 3x in the same column as the x to the power 1 level. That's very, very important. If you write it in the front, you're just going to confuse yourself. Right? So take all the confusion out of the equation and remember to keep your columns correct. X squared, x, and then the single numbers. Now, once we've done that, we go to the next level and we say, all right, so if I take this 3x and I multiply it by my divisor, very important, what am I going to get? And what I do is I write that down at the bottom. And I say, right, this is what it is. So 3x multiplied by x is 3x squared. 3x multiplied by negative 4 is minus 12x. Next thing we do is we subtract them from one another. Now, when you subtract, you're adding the inverse. So, 3x plus minus 3x, that's adding the inverse, ends up in a 0. And 11x plus 12x, remember, you're adding the inverse. When you're subtracting, you end up with x here. Drop the 4 down. That's the next step, is you drop this 4 down and you say, let's start again. And how do we start again? This way. X goes into x once. And we write down the 1 plus 1. And notice I've tried to keep it above the single layer. Right? These should all be above each other. Next step is we take the 1 and we multiply the 1 by the divisor. So 1 times x is x and minus 4. Wow, it's worked out perfectly. Because when we minus this, we get a 0 at the bottom. So we've got no remainder in this case, and that is our technique. So to get back to our original problem, that polynomial divided by that polynomial equals 3x plus 1. Okay, so let's take this to the next level. We need to do a more complex problem, and I'm going to teach you the last trick that you need to be very sure you do right up front when you're trying to do algebraic long division. Let's look at this problem. X to the power of 4 plus 49x minus 4 minus 23x to the power of 3. Now we know the first thing that we want to do is we want to rewrite both of these parts of the division problem in descending powers of x. But there's another trick over here, because in the first expression we don't have an x squared. And what you need to do is you need to write that as a 0x squared in there. It's actually a 0, but write 0x squared so that you can keep your descending powers of x there. Very, very important little trick. And you'll see why. It just assists you in keeping things together. And if we've written this in descending power, we've now got a problem that we can actually deal with. So let's put them into our little bracket. And we've got the divisor and the dividend. And we now want to ask ourselves, x squared goes into x to the power 4 how many times? And it's x squared times. Very important to see where I wrote that. I wrote that above the x squared column. If you write it in the front, I'm going to say it again, it's going to just succeed in confusing you even further. So take out any possibility of confusion when you're doing these problems and write it down there. I can also just digress slightly and say write neatly, understand what you're doing, write neatly so that you don't confuse yourself by bad handwriting either. Now, the next step is we take the x squared and we multiply it into the divisor and we get the answer. And as we know by now, right, we sort out the sign, we've sorted out the sign, and we now need to subtract that from the top equation. And when we've subtracted, and remember subtraction is the inverse of adding, we end up with this. The x to the power of 4 minus x to the power of 4 has ended up in a 0. And we've got this equation there. And finally, we drop down the 49x into the next layer. We now ask ourselves the question. X squared goes into minus 24x to the power 3 how many times? And the answer is a negative 24x. When we've got the negative 24x, we now are going to multiply that back into the divisor and write it down at the bottom. Next step is we subtract them again. That turns out to be a 0 again. That first part of the problem. And we end up with 26x squared plus 1x minus 4. Now we ask ourselves the question again. X squared, the first term of the divisor, going into 26x squared, and that goes in 26 times. So, now we take the 26 and we multiply the 26 into the divisor, and we get this answer. 26x squared plus 26x minus 52. And now, once again, we do a subtraction. And when we've subtracted this, we end up with that result. Now, we cannot continue, and I need you to look at this very, very carefully. Where is the point at which we cannot continue? X squared cannot go into x. So we've gone below that index of x. The index of x there is 2, and the index of x here is 1. So the 2 is larger than the index of 1. So x squared cannot go into 25x, so we know that is our remainder. But if you remember what I said in the very, very first part of this video, is this minus 24x plus 48 is a remainder, but it is the fraction of the divisor. So we take that fraction and we move it up and we say that 25x plus 48 is a fraction of the divisor. And this is the real answer of this long division problem. Thank you. That's all from Maths for You for today. Subscribe if you find these videos good or if they're assisting you. Give me a thumbs up or a thumbs down. Doesn't matter. But if you want to be warned when I create new media, click on the bell. There are many more benefits if you go to the website www.mathsforyoutoday. That's our official site. These videos are there, plus a whole bunch of other problems and tutorials. Go and have a look. Thank you very much. And as a final note, especially to all of you out there that might be struggling with maths, think positive. Once you've mastered a lot of these techniques, math actually becomes a pleasure. And if math is a pleasure, life becomes a pleasure as well. Thank you very much.